Hi there friends and subscribers, welcome back to Daniel's Tech World on YouTube. My name is Daniel Rosehill. This is my tech YouTube channel. Recently we're talking a lot about optical media because it is great for archival. Still in the year 2024 has a lot of relevance and a great little tool if you're using a Linux distro for your computing to know about is this tool called dvdisaster. You can pick this up on GitHub. And it really is very, very powerful. Like a lot of Linux software, it looks quite basic. What it can do is actually incredibly useful potentially, by which I mean it creates error correction code, which has a ECC file type, standing for error correction code. And what it does is you can create this while your disk is good, right? The ideal situation is that we don't want to use the ECC code. But if stuff does get corrupted, we can use this for recovery potentially to recover the lost data. So what you're looking at here is some photographs that a friend took and I decided to archive as a volunteer effort. So what I'm going to do firstly is put these into a ISO file. The reason I'm doing this is dvdisaster likes to work at the file image level. So I'm going to call this pics.iso, and we're going to put this here in desktop. Well, we can put it on the desktop. That'll be just fine. So it takes only a second, as you saw, and we have now got an ISO file that is 273 megabytes in size. Now, what we're going to do is move over into our dvdisaster, and what you need to do is go into the preferences. By default, the error correction code generated is going to be of the RS01 algorithm. We have three options here. One is going to, RS01 says, okay, let's create some error correction code that you store elsewhere, and we can use that potentially to recover the disk. RS02 is what's called an augmented image. What this means is that we're going to take what we're burning, and we're going to put a little bit of ECC, and we're going to actually put it on the disk. The risk of RS02 is that if the disk is completely destroyed, like it's unreadable, the ECC code will not help us potentially. Of course, if the disk is destroyed physically, like by a jackhammer, nothing will help us. The original data is going to be pretty much gone. But we have different scenarios. So let's put the jackhammer aside for a second. If we have the disk is just a little bit corrupted, we can either take from the ECC data stored elsewhere, or more conveniently, we can put it on the image. RS03 is kind of a best of both worlds approach. We can use this to put stuff on the disk, and we can also take that same data and put it off-site. So today we're going to be doing RS02. And the way this works is it kind of says, you can see here the different forms of optical media it has saved in its memory. Like it knows this is how much data is on a CDR, this is how much data is on a DVD, and it's going to create a certain amount of data that's not going to overshoot the capacity of that medium. So I'm going to tell it today that we're going to be using well, it's not really working so well. We're going to tell it it's going to be trying to put data onto a CDR, which is what we're burning onto. For some weird reason, the data in the CD is not populated by default. So I'm going to populate it 333,000 sectors. You can see that the other media is set into the million. So it's going to go for as small as possible. So that is good. And it knows that we're writing onto a CD. So the next thing we need to do is tell it where the ISO file is. So I can go into the desktop and we can see where we're going to put it. We just need to point it to the ISO file that we have. And we can see on the right here that we have marcuspics.iso. Now we are going to try to create this data according to the, you can also tell it where to put it. So we're going to say put it on the desktop and call it photos.ecc or photos.ecc for error correction code. And now we're going to create this error correction code. Okay, so by populating the data for a CD, it didn't have it by default. And if I didn't specify the amount of sectors to fill up to, it would have overfilled the CD. I think it's just kind of like thinking that people aren't using CDs anymore. So if by any odd chance you are trying to use a CD, you'll want to specify the maximal amount of sectors as 333,000. That's the sectors on a CD. So it's filled up the ISO file that we had before up to 646 megabytes, which, as we know, is okay for a CD. It's going to fit in the CD capacity. And the pix.iso file on our desktop, which is now 646 megs, has not only the original data, it also has the ECC code built into it. So the last step is all we need to do is to write this onto a CD. So this step is pretty easy. I'm just going to go for a new project, new data project. I'm going to go to my desktop and I'm going to go for markuspix.iso. Then I just need to add this into the project, and you have the option as usual in K3B, do you want to add the ISO as a file, which you can do. But once you're trying to add an ISO, it's going to say, would you like to burn that image? And you're going to go for that option. We're going to make an image out of this, and it's going to be 646 megs, which is going to be the stuff we're protecting plus the ECC data. And we're going to put that onto a CD. And if you want to, you can also verify the checksum, but I never really do this. You can simulate if you want, and in advanced options, you have the data mode. Speed is going to be auto, writing mode auto, and we're going to just put this onto the CD and wait for it to burn. This method of putting error correction onto a CD is not ideal, in the sense that my recommendation for people archiving stuff onto optical would be, well, let's put stuff onto the M disk. That's my recommendation. Always, it's the only form of archival that was built to actually hold data perfectly or immutably for the long term, because it's putting it into an inorganic layer. LTH Blu-ray kind of had the same technology. If you can still find those, they're decent to use as well. But that would be my top recommendation. But if you are doing something, this is an interesting little kind of experimental process, if you want to put it like that, because you can use really, really crappy CDs or DVDs like what I'm using for this burn. And you can see by putting a bunch of ECC code on it, can you set yourself up for a situation whereby if the stuff gets corrupted, that you're going to be able to use this code. And it's kind of another way of making use of, if you have spare capacity on a CD project or a DVD project, you can put on parity data, but ECC is supposed to be a bit better. So if you're using Linux and you're burning stuff for not that much work, I would encourage you to use dvdisaster. Which algorithm would I go for? I would personally go for RS02. And put stuff on the disk itself, and also put stuff on your NAS or your stored file system, because you're just giving yourself all the possible options that if the original stuff gets corrupted. I'm currently doing a CD aging experiment. I'm putting some CDs out to age or get destroyed in the wind and rain. And I took some ECC data snapshots from that, and it's going to be interesting to see, can we use that to restore corrupted sectors on the disk. Hope this has been interesting. This is burning away, so we've reached the end of the video. And thanks for watching. And if you have any thoughts about optical media and error correction code and parity, let me know. Thanks for watching.